Okay, now I have this stapled out of order is what I want you to do. Okay, I want you to plug the following expressions on the calculator. So log 3 times 4. So log, parentheses, open up, hit 3 times 4. Okay. 1.08. Okay, now I want you to do something different. I want you to go log 3 plus log 4. Close the parentheses after you punch that in before you hit plus. Oh, what do you notice? They're the same thing. That's because the operations times and plus, when dealing with logarithms, are kind of synonymous. Times and plus are partners. Okay, now, I want you to go log 12 divided by 3 divided by 4. Okay, 0.47 or 48. And then log 12 minus log 4. Oh, same thing. Well, that would lead me to the conclusion that division and minus are synonymous when dealing with logarithms, okay? Now, one thing you notice, this is a much shorter expression than this, okay? And this is kind of weird, but it's very easy. Okay, now turn to the first page, and here's what the first page is about. What does the word condense mean? The word condense means shorten the expression. Well, you have log twice, both base 6. Your job is to make this expression, shorten it, so that log base 6 appears only once. Okay? And here's what you do afterwards. If you have coefficients in front of the logs like this 5, you bring that around and that becomes a power on whatever's here, in this case x. There's no coefficient here, so that's 12. So what comes after the first log base 6? Looks to me like x to the 5th. Okay, so write that down. Then when I am shortening the logarithm, when I come across a plus operation, I write multiplication when I'm trying to condense it. And then go look at our next log base 6. What comes after that? A 12. Now it has been condensed. This and this are equivalent expressions. Okay, now the next one. I've got 3 different logarithms, okay? And my job is to make it so there's only one. Now, if I don't see a little base on the log like I did with this 6 to the bottom right, the base is automatically 10, okay? So I put a 10 right there. So the coefficients need to come on over here as powers. X to the 6th, y to the 5th. Okay, now after the first log base 10, we got 3 to the 2nd. Now that you can simplify that. That's 9. Okay, and then plus is synonymous with times when I'm condensing. Then x to the 6th comes after the second log base 10. Remember, plus is synonymous with times. Then y to the 5th. Okay, that's the answer. Okay, now I have log twice. My job is to only create one logarithm. They're base 2. There's no coefficients I need to put around as powers. After the first log base 2, I have 6. Now remember, minus is synonymous with divide, okay? So what I do is I underline the 6 instead of putting a multiplication operating dot. After the second log base 2 becomes an 8, okay? Now you can leave your answer like that. You can also reduce 6 over 8 to 3/4. Either way is okay. Okay, now my next one. Remember, if I don't see the base number, it's automatically a base 10. By the way, this y I wrote really screwed up. That y should be bigger. The base is 10. Okay, so I have two logs. My job is to condense this so there's only one singular logarithm. Okay, so log base is 10. Now we need these coefficients to come around as exponents. Okay. Okay, so x to the 6th. And then minus is synonymous with divide. So instead of a multiplication dot, I underline to signal we have a division operator, and then y to the 2nd. Can't simplify that, that's the answer. Now pause this video right now and go do 1 through 4. Remember, if I don't see the little base, it's a 10. Okay, now you're doing the opposite thing. You are going to expand the expression. So here's the key to expanding. After the log base 4, you're going to expand that so there's a bunch of log base 4s. Well, to know how many log base 4s, we need to know how many factors there are. Well, I put a multiplication symbol between 5 and x, and a multiplication symbol between x and y to the 2nd. So how many factors is that? 1, 2, 3. You are going to write log base 4 out 3 times. Give yourself a lot of room between them. So the first factor is a 5. Then I have a times, so if I'm expanding it, that becomes plus. My second factor is an x, another times, so plus. And my final factor is y to the 2nd, but now the power comes around here and turns into a coefficient in front. Done. Okay, remember if I don't have a base, it's a base 10. Okay, 10's your little number. So how many log base 10s do I need? Well, I've got a factor of 8, a factor of x to the 3rd, so that's 2 factors. Okay, so I put 8, and after time, instead of times, I put plus. And after the 10, we put x to the 3rd. But then the 3 needs to come around and become a coefficient instead of an exponent. Okay, next one, I have a log with a base of 8. So how many times do I need to write that? Well, I got 3 times x to the 2nd times y to the 3rd. So there's 1 factor, 2 factor, 3 factors. So I need log base 8 3 times. Okay, so I have 3. Instead of times, I write plus. And then x to the 2nd, and then the times is replaced with plus, and then y to the 3rd. Now those powers need to come around to the front now as coefficients. Okay. Boom. Done. That's all you do. Log, what's a base you put there if you don't have one? A 10. So how many factors do I have here? Well, 1, 2. Obviously, I don't have the multiplication symbol, so there's 2 factors. Okay, I put a 4. Now remember what division is replaced with now that I'm expanding it. Instead of divide, it's going to be minus x. Okay, that's done. There are no exponents. I don't need anything to come around to the front. Okay, now you should be set up nice for 5, 6, 7, 8. Remember, get base 10 if it's not there.